So in this video, we're going to talk about Taylor series, or not Taylor series, Taylor polynomials. Taylor polynomials are really useful polynomials. Well, the first thing about Taylor polynomials we should know is that they are polynomials, meaning they are x to some power plus x to some other power plus x to some other power. And they are strictly composed of the addition of a variable to some power. In this particular polynomial, or in all polynomials, we don't have any variables of a form other than x to some power. And this is very useful because we know exactly how to integrate, how to differentiate, and how to manipulate polynomials, whereas other functions are slightly more difficult to determine their integrals or differentials. So a Taylor polynomial, basically what it does is it approximates some function as a polynomial. And actually, you've been doing this all your life, or not all your life, but for quite a long time in your academic life without knowing it. For example, let's say we wanted to approximate the square root of 5. And so I'm going to draw my square root function. I really hope that's a square root function. And say, well, this is 1, 2, 3, 4, 5. 5. I know exactly that the square root of 4 is 2. I know that the square root of 9, I hope this is 9 here, is 3. So 5 does lie somewhere between, the square root of 5 lies somewhere between 2 and 3. And one way that we can find the approximate value of the square root of 5 actually is if we drew a tangent line. Let me find my tangent line. I hope I get this one. This is a tangent line. So if we draw a tangent line, and we pretend that it's tangent to the point 4, 2, and it passes through the point 4, 2, because we know exactly that the square root of 4 is 2, then we can get a pretty good approximation of what the square root of 5 is, right? Because these two numbers are fairly close to each other. These two numbers here, these two values are fairly close. So we will get a fairly decent approximation. So to find the equation of this line, what we do is, to find the equation of any line, is we need the slope. So the slope of this at this tangent would be the derivative of this function at this point. So f prime of 4, the derivative of the function is half the square root of 4. So this is 1 over 4. So we know the slope of our line is 1 over 4. And in order to create a line, we need one slope and one point. Because if we know that every unique line has its own slope and passes through a specific point. So then we can say formula of a line is y minus y naught equal to the slope, which is, I'm going to call m, times x minus x naught. So in this particular case, we have y minus 2 is equal to 1/4 of x minus 4. Yes. So we have y is equal to 2 plus 1/4 of x minus 4. This actually is what we call the first order or linear approximation or first order Taylor polynomial, because we've approximated, because a line is actually a polynomial of the degree 1, and we use the line to approximate the square root of 5. Now what if instead of using a line to approximate the square root of 5, we can use something that's a little bit more accurate? For example, imagine instead of using a line, we can use a parabola at which the second derivative at this point is equivalent to the function. So then our parabola would look, this is a bad parabola, but would hopefully look something like this. And so then I actually get a slightly better approximation. To obtain this approximation, we have to use the Taylor formula here. The T stands for Taylor, where N denotes the nth order expansion, and C denotes where we've centered a polynomial. So in this example, we centered our polynomial around 4, and we found that when n is 0, so the summation from 0 to I guess not infinity, but rather we're summing it to however many polynomial approximations we need. And so in this case, when n is 0, we have the function itself evaluated at 4 times x to the power of 0 is 1, and 0 factorial is 1, so we have 2. And then when n is 1, we get plus 1/4 minus x times x minus 4. And when n is 2, we get minus 1/32 over 1 over 2 factorial times x minus 4 squared. And so this would be the second order Taylor polynomial expansion centered at 4 of the function the square root of x. And so if we approximated the square root of 5, we can say that it's equal to 2 plus 1/4 minus 1/64. And this approximation is slightly better than our linear approximation.